right, welcome back. Today we're going to be looking at a lesson on writing equations of lines. And this is where we're going to take everything that we've learned in this unit and put it all together. So up to this point, we have looked at how to solve an equation. We've looked at rearranging equations. We have looked at the slope formula. We've talked about what slope is. We've looked at how slope relates to rate of change. We've looked at one form of the equation already, y equals mx plus b, so the slope-intercept form. We've looked at what the m and the b represent, and then we've also taken those equations and graphed them on, or graphed the lines on a grid. Now we're going to go in a different direction. We're going to look at properties of a function on a graph, and then we're going to determine the equation of that function. So you'll be able to look at a picture and make an equation, or take properties from that graph and make an equation. So before we get into that, we're going to look at a review of what we've done up to this point. So in the last class, in your assignment, you were asked to determine the equation of a line using y equals mx plus b. Well, if you remember, the slope-intercept form y equals mx plus b tells us two really important things. It tells us m, so it tells us the slope, and it tells us b, which is the y-intercept. Hence why we call it the slope-intercept form. Just as a refresher, if we're talking about y-intercept, that's where our graph crosses the y-axis. All right? So if we're given a question like this, it says, write the equation of a line in the form y equals mx plus b with the slope 3 that passes through 0, 4. Well, slope is our m, and 0, -4 is our y-intercept, and it tells us that b is -4. So our equation is going to be y equals 3x minus 4. All right, so looking ahead, we're going to be talking about 3 different types of equations, and I've introduced these before but didn't talk about them in great detail. We've already looked at the slope-intercept form, and again, we know that m stands for slope and b stands for y-intercept. The next formula that I'm going to introduce you to today is the point slope form. And so this is written as y minus y1 equals m times x minus x1. And if you look at it, you can almost see that the slope formula is embedded in here. But what this would represent, or the key points from this, are our slope. Okay, so m equals slope, and a point. And that point would be x1, y1. So again, we call it point slope form because it represents a point and a slope. So if we're looking at a word problem and we're given the point on a graph and we're given the slope, we can go straight to writing our formula. Now, it's important too to notice the negatives there. So y minus y1 and x minus x1. And notice that my coordinate is x1 and y1. So we're pulling them straight from there. So for example, I had something that said y plus 4 equals m times x plus 5. My coordinate would actually be -5, -4. There's also a common mistake where we mix up our x's and y's, and that's because we're used to always writing x, y in our coordinate, but in this formula, y is on the right and x is on the left, so just be careful not to mix those up. Now when we get into the general form, we're looking at ax plus by plus c equals 0. I'm not going to talk about this equation at all today. We're going to have a whole separate lesson on that formula. All right, so let's take a look at the point slope form, or when you look at some textbooks, they call it the slope point form. So the example says the equation of a line in point slope form is y minus 3 equals -1/2 times x plus 5. And we're asked to draw a graph that represents the function. So the first thing we're going to do is look at what information we're given. Again, if you look at the formula above, we've got y minus y1 equals m times x minus x1. So the -1/2 is our slope. So m is going to equal -1/2. And then our point, this relates to our y1, and this is our x1. But remember, the formula is y minus y1 and x, or m times x minus x1. So our coordinate is actually -5, +3. Once we have our slope and our point, then we just have to graph. So if you remember when we were doing the slope-intercept form, we plotted our y-intercept and we counted our slope. We do the same thing here, except we're starting with a different point. So we'd start at -5, 3, Make sure you're indicating your scale on your graph. So -5, 1, 2, 3, 4, 5, up 3, 1, 2, 3. There's our point -5, 3. And then our slope is down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2. Again, we'll get our ruler. And connect our points. I think the more I teach this unit, the more cooperative that ruler gets. All right, so there we have our equation. All right, so let's take a look at the next one. If we're given a graph, we can go from the graph to our equation. And again, if I look at that equation, we've got y minus y1 equals m times x minus x1. So one of the reasons that this point slope form is so valuable is because sometimes we don't always know what our y-intercept is. If we're going to use the slope-intercept form that we've had from before, we have to know what our y-intercept is in order to graph it. In both of these equations, we can find our slope, or we need to find our slope. But the first equation, y equals mx plus b, we have to have slope and y-intercept. With the point slope form, we have to have slope, but we can choose any point on the graph. So this is a more valuable equation if we can't clearly identify what our y-intercept is. And if you look at this graph, that's exactly the case here. We don't know exactly where that y-intercept is. We can guess that it's probably around 1/2, but we don't know for sure. And so this graph is going up by 1s. So I'll label the scale. We're going to look for some point on the graph that's clearly identifiable. I'm going to go with this one here, which is 1, 2, 3, 4, 5, -5, 3. And I chose to use this point here, which is 1, 2, 3, 4, 5, 5, -2. So those are the points I chose. There are certainly other points on that graph that also are clearly identifiable. If you want to try using other points, you should still get the same equation as me using the same methods. So the first thing we're going to do is figure out our slope. And so for slope, if you remember, slope is y2 minus y1 all over x2 minus x1. So using my points, -5, 3 and 5, -2, it's helpful to label your points. We would have -2, so m is going to equal -2 minus 3 all over 5 minus -5. So that gives us -5 all over +10, which is -1/2. Okay, so that's going to be our slope. Now to build our equation, we go y minus y1 and x minus x1. So I've already chosen -5, 3 as my x1, y1. So writing my equation is going to be y minus y1, so y minus 3, equals m, which is -1/2, times x minus x1. Well, that would be x minus a -5. So simplifying, I have y minus 3 equals -1/2 times x plus 5. Well, what if I had decided to make the other coordinate my x1? Well, I could have the same slope because it's all in the same line. So I'd have y minus -2 equals -1/2 times x minus 5. Simplifying, that gives me y plus 2 equals -1/2 times x minus 5. And so you're probably looking at those two equations and saying, well, they're not the same thing, so how could they possibly be correct? Well, I want to show you how I know they're the same thing. If I were to multiply these equations out, they should simplify to the same equation. So I'm going to convert these both to slope-intercept form, and they should be the same. So I've got y plus 2. I'm going to multiply through here. So -1/2 x plus 5 over 2. and I'm going to subtract my 2, so I'm going to have negative 1/2 x. 5 over 2 minus 2. 5 over 2 minus 2 is 1/2, so positive 1/2. So this is the exact same equation written in slope-intercept form. So this one here is point slope, and this is the y equals mx plus b. So slope-intercept. Well, let's take a look at the other equation. I've got y minus 3 equals negative 1/2 times x plus 5. We're going to simplify. We'll multiply these through. So I'm going to have y minus 3 equals negative 1/2 x minus 5 over 2. If I add 3 to both sides, I'm going to have negative 1/2 x plus 1/2. Notice this also simplified to the exact same equation. So when these are written in slope-intercept form, they will always look the same. When we write them in point-slope form, they won't always look the same because it depends on what point we picked on the graph. But as long as the point we've picked, as long as the points that we pick are all on the same line, the equation should all simplify down to y equals mx plus b. So as we go forward here, I'm going to show you 2 methods for every example. And so as you're doing these, what you might consider is watching each type of question that you could get. Watch that section of the video, go to your assignment, do some of those questions, come back and watch the next section. I would strongly encourage you not to watch this entire video all at once. All right, so the first type of example we can have is writing equations of lines. And the first one we're looking at is given slope and y-intercept. So this would be the most basic one that we were given, and we've already done some practice with these. Now what I want to point out is that unless you're told otherwise, your final equation would be expected to be represented as y equals mx plus b. We're going to get into some other equations in the next lesson with general form, and then I'll be asking you to switch back and forth. But in the end, I want you to use y equals mx plus b. That being said, you might find it easier to start with point slope form and then just multiply it out to get slope-intercept form. All right, so if you're given the slope and the y-intercept, then immediately we're going to jump to using the y equals mx plus b because we're given the 2 pieces that we need for the formula, slope and y-intercept. So the first question says m equals 3/5 and the y-intercept is 0, 2. So the 2 would be our b value. So our equation is going to be y equals 3/5 x plus 2. And then the next one, it says m is negative 1/2 and the y-intercept is 0, -5. So we would have y equals negative 1/2 x minus 5. All right, so that's the first type that you're going to see. Another one that might be another type of question that you could see is when you're given a slope and a point. Well, then this would make sense to use the point slope form. But you can do it with slope-intercept form as well, and I'm going to show you both methods. So method 1, going forward, whenever you see method 1, I'm going to use point slope. Method 2 will be slope-intercept form. So method 1 is going to be to use point slope. And so we're told that m equals -2 and it passes through the point 3, 2. So this would be like our x1 and our y1. So using our formula, y minus y1 equals m times x minus x1. We're going to write y minus 2 equals -2 times x minus 3. Now, if you were told to just leave it in point slope form, that's where we would leave it. But again, unless told otherwise, you want to multiply it out to be slope-intercept form. And so we're going to have y minus 2 equals -2x plus 6. Simplifying, we've got y equals -2x, a positive 6 plus 2 is a positive 8. Okay, so y equals -2x plus 8. If we wanted to do this exact same question but use the slope-intercept form, this is what it would look like. So method 2, slope-intercept. Now, when we're doing the slope-intercept form, the 2 things that we care about is the slope and the y-intercept. And so when we have questions like this, we're not given the y-intercept explicitly, so we have to kind of hunt for it. So we start off with y equals mx plus b. We sub in what we know, and then we solve for what we don't know. So our y value is 2. Our m is -2, our x is 3, and the unknown is b. So we're going to simplify and solve for b. 2 equals -6 plus b. We add 6 to both sides. 2 plus 6 is 8. 8 equals b. Once we know the slope of -2, and we know the b value is 8, then we can write our equation. Y equals -2x plus 8. And if you notice, it's exactly the same as the one on the left. So as we go through these, I'm going to go through them slightly quicker, but I'm still going to show you both methods all the way through. And as you're doing that, I want you to pick the method that's best for you, or you might use one method for one type and one method for another. All right, so the next example, we've got m equals -2/3, and it goes through p, -1, -5. Sorry, -2, -5. So we're going to start off with method 1. Y minus y1 equals m times x minus x1. It's going to be y minus a -5, so y plus 5 equals a slope of -2/3, and x minus a -2, so x plus 2. That would be where we would leave it if we were doing point slope form, but again, we want to convert it to slope-intercept. So -2/3 x minus 4/3. Now, quite often you're going to be seeing fractions as we work through this lesson. Use your calculator to your advantage. Plug in the questions if you're not sure. If you didn't know that -2/3 times 2 is -4/3, then use your calculator, use the math frac to help you out. So y is going to equal -2/3 x minus -4/3 minus 5 is going to leave us with a -19/3. So if you weren't sure what that would look like when you're doing it on your calculator, we would be taking -4/3 and subtracting 5. It's going to give us a decimal, and then we're going to go math frac, and we get -19/3. So again, don't be surprised if you're coming across some really strange fractions. When we get into the general form in the next lesson, you'll see how it can be nice when we don't have to deal with the fractions. All right, method number 2. Using the slope-intercept form, we've got y equals mx plus b. We know that y is -5. We know the slope is -2/3. We know x is -2, and we're looking for b. So we multiply and solve for b. So -2/3 times -2 is -4/3 plus b. Oh, sorry, +4/3. And so in -5, take away 4/3 is going to give me -19/3. Once we have our slope of -2/3 and our y-intercept of -19/3, our equation is y equals -2/3 x minus 19/3. We're going to keep going with this point and slope, but other ways that I can ask you this question in a slightly different way is to bring in the parallel and perpendicular component. So if you remember, parallel lines have the same slope. So we're going to try to determine the equation of a line that is parallel to the equation given and passes through the point 1, 2. So we're going to have an equation. We're going to have an equation that might look like this, but I want to find the equation of a new line that's parallel to that point, but goes specifically through point 1, 2. So they're going to have the same slope, but go through a different point. So the first thing we have to do is find our slope. That it doesn't matter which method we're using, we've got to find our slope. And so I'm going to rearrange that equation, 3x plus 4y equals 10, to solve for y. Subtract 3x, and 4y equals -3x plus 10. Now when you're rearranging equations, some people are still having some difficulty with manipulating the equation. A trick that I've given students in the past is to think that when we're moving a term from one side of the equation to the other side of the equation, the signs change. So if you switch sides, you switch signs. Switch sides, you switch signs. And so if that would be something to help you when you're manipulating your equations, keep that in mind. When you switch sides, you switch signs. I'll mention that a couple times as we're working through some of these. So we moved the 3x over, so it was a positive 3x, now it's a negative 3x. So negative 3x plus 10, I'm going to divide by 4, and y equals negative 3 over 4x plus 10 over 4, which simplifies down to 5 over 2. Now, it doesn't really matter that it simplifies to 5 over 2, because all I ultimately care about is the slope. We're told that we're finding an equation that's parallel to that equation, and so if the slope is negative 3 over 4, the parallel slope is also negative 3 over 4. So that's where we start. Now, method 1. For doing method 1, we're starting with y minus y1 equals m times x minus x1. Our y value is 2, so y minus 2. Our slope is negative 3 over 4, and x minus 1. Multiplying everything out, we've got y minus 2 equals negative 3 over 4x plus 3 over 4. Adding 2 to both sides, we've got y equals negative 3 over 4x. 3/4 plus 2 gives us 11 over 4. So again, if you're doing that on your calculator, you're going 3 over 4 plus 2, and then you can math bracket from there. Looking at method 2, we have our slope. We have our slope of negative 3 over 4, and we have our y value of 2 and our x value of 1. So y equals x was 1 and y was 2. So our slope is negative 3 over 4. Our y value is 2. Our m value is negative 3 over 4. And our x value is 1. So negative 2 equals negative 3 over 4 plus b. 2 plus 3 over 4 is going to give me 11 over 4. Again, once I know my slope, which was negative 3 over 4, and my b of 11 over 4, I can write my equation. So y equals negative 3 over 4x plus 11 over 4. Now, as we're going through these, hopefully you're starting to figure out which method makes more sense to you. I want to expose you to both, but let you decide which one works for you. All right, so we're going to look at an example that relates to perpendicular. It says, given the equation x plus 6y minus 18 equals 0, find the equation of a perpendicular line passing through 4, negative 1. So there's our x, and there's our y. If you remember, perpendicular means we're looking for a negative reciprocal. So the only reason that we even care about this equation is because we want to find its slope so we can take that and do the negative reciprocal. So we start off with x plus 6y minus 18 equals 0. If you remember that trick I gave you, if you switch sides, you switch signs. We want to get y by itself, so we're going to have 6y. We move the x over, it's a negative x. We move the 18 over, it's a positive 18. And then to get y by itself, we have to divide by 6. So y equals negative 1/6 x plus 18 over 6. Now you can reduce the 18 over 6. I'm not going to bother because I don't really care about it. Okay? All I care about is my slope here. Now, if we were doing a parallel, if we were looking for an equation that was parallel, we would use negative 1/6. But we want something that's perpendicular. And so the equation, or the slope that's perpendicular to negative 1/6 is going to be a positive 6. And so that's what we're going to be using for the rest of this question. So if we look at method 1, we've got y minus y1 equals m times x minus x1. So y minus a negative 1, so y plus 1 equals 6 times x minus 4. Multiplying this out, y plus 1 equals 6x minus 24. Subtracting the 1, 6x minus 25. Now, if we look at method 2, If we look at method 2, y equals mx plus b. Our y value we had was, -1. So -1 equals m, which is 6, times x, which is 4. And again, we're looking for b. So -1 equals 24 plus b. -1 minus 24 is -25 equals b. Once we have our slope of 6 and our y-intercept of -25, we can write our equation. Y equals 6x minus 25. All right, well, hopefully you're still with me, but hopefully you've taken a couple breaks. All right, we're going to be moving on to the final method, or the final way that I can ask these questions. And this is when I give you 2 points and you have to find the equation of the line. Again, remember that no matter what equation or what method we're using, whether you're using point slope or slope-intercept form, ultimately the first thing I care about is slope. So you're going to take these 2 coordinates, find the slope, and then from there decide which method you want to use. So when you're doing slope, remember you want to label your coordinates. And it does not matter which one is x1, y1, and which one's x2, y2, as long as you don't mix up your 1s and your 2s. So we'll start by doing the slope formula first. So m equals y2 minus y1 over x2 minus x1. So we're going to have 3 minus a -5, so 3 plus 5, all over -1 minus 3. So that's going to give us 8 over -4, which is -2. From there, it does not matter which method you choose. Again, I'm going to do both of them throughout. So method 1, we're going to do y minus y1 equals m times x minus x1. So as we do this one here, we've got to pick a point. And so it doesn't matter whether you use x1 or x1, y1 or x2, y2. What I'm going to do throughout is I'm going to choose one coordinate for method 1 and the other coordinate for method 2, and I will still get the same equation in the end. So that should hopefully show you that it does not matter which point you pick. But I'm going to choose this one here. We've got y minus y1, so y minus a -5 gives me y plus 5. My slope we found was -2, and x minus 3. Multiplying that out, we're going to have -2x plus 6. Y equals -2x. 6 minus 5 is a positive 1. So we're going to have y equals 2x, or -2x plus 1. Now, if we're using method 2, y equals mx plus b. Again, for this equation, I care about slope and I care about y-intercept. We have the slope, we have to find the y-intercept. So we pick any random coordinate that we want. I'm going to choose this one. As long as it's a point that's on the line, it should work. So my y value is 3, my slope is -2, my x value is -1, and we're looking for b. So we simplify first. 3 equals -2 times -1 is a positive 2. 3 minus 2 is 1. Once I have my slope and my y-intercept, I can write my equation. Y equals -2x plus 1. All right. At any point, if you want to pause the video and try these on your own first, that would be a good idea, and then you'll know if you're on track. All right, next example, it says we're looking for an equation that passes through the points -2, -4, and -5, 1. Again, when we're given 2 points, it doesn't matter what method you choose, we got to start off with slope. So m is going to equal 1 minus -4, so 1 plus 4, and -5 minus -2, so -5 plus 2. Again, if it helps, label your points. So 1 plus 4 is 5, -5 plus 2 is -3. So we're going to have -5/3. Again, don't be intimidated by fractions. You can always use your calculator to help. So method 1, we're going to go y minus y1 equals m times x minus x1. Now, it doesn't matter what your x1 and your y1 is. I'm going to stick with the ones I've labeled, but you can certainly switch it up. So y minus a negative 4, y plus 4. M is 5 over negative 3, or negative 5/3. And then x minus a negative 2, so x plus 2. Multiplying out, y plus 4 equals negative 5/3 x. And negative 5/3 plus 2 is negative 10 over 3. Subtracting 4, we're going to have negative 5/3 x minus 22 over 3. So again, if you've forgotten the calculator piece, it's negative 22 over 3 minus 4, and then math frac. Using method 2, we've got y equals mx plus b. So I'm going to use this coordinate right here as my y and x. So y is 1, m is negative 5/3, x is negative 5, and b is what we're looking for. Simplifying, we're going to have negative 5/3 times negative 5, which is 25 over 3, plus b. All right, and then we're going to go 1 minus 25 over 3. So 1 minus 25 over 3 is going to give me negative 22 over 3. And my equation, when I have my slope and I have my y-intercept, my equation is going to be y equals negative 5/3 x minus 22 over 3. Again, as we're doing these questions, hopefully you're noticing that it doesn't matter which variable we choose, which coordinate we choose, we should still get the same answer. Now, if you want to try one on your own, there's an example here. I will write out the answers. I'm going to use both methods again, but I'm not really going to talk through this one too much. I'm just going to write out the math and let you watch as it goes. So again, maybe try it on your own, pause the video, try it on your own, and then come back to check your answers. Now, as you're following along with that, you may have noticed that your methods or your numbers look very different than mine, and that may have been because you chose a different coordinate than I did. But hopefully in the end, you still got the same equation. So if you notice, this time I made this my x1, y1, and I made this my x2, y2 when I was working with the equations. All right, one last piece, and this is probably the easiest of everything we've talked about. We've already looked at the special cases with horizontal and vertical lines, but I want to look at those equations one more time. So it says write the equation of each line below. When we have a horizontal line, it's going to be y equals something. So horizontal lines are always y equals something because our line stays constant on a y value. And when it's a vertical line, it's going to be x equals a number. And so if we look at the first one, we have a horizontal line, so we know it's y equals. If you didn't know it was y equals, look for what's staying constant all the way along. And what's staying constant is 2, 3, y equals 3. So this equation would be y equals 3. And actually, we have a vertical line, so I know that it's x equals, but if I didn't know that it was x equals, I would look at a bunch of coordinates and ask myself, what's staying constant? It's the x value that's staying constant, and it's an x value that x equals -1. Now, when it's an x equals or a vertical line question, we couldn't really use our slope formula to figure this out because our slope is undefined. But when it's a horizontal line, if you had completely forgotten that it was y equals, you could use your slope formula, you could use 2 points on there, and you would still come out to y equals 3. All right, sometimes you're not going to be given a graph, you're going to be given some descriptors. So the first one says the question says write the equations of the following lines. And the first one says the slope is 0 and it passes through 2, 3. Well, the slope of 0 tells me that it's a horizontal line. So sometimes it's helpful to draw a little sketch. We know it's a horizontal line and we know that it passes through 0.2, 3. So a horizontal line passing through points 2, 3. It's a really wonky looking horizontal line. But if it's going through 2, 3, the part that's staying consistent the entire time is the 3, and that's a y value, so y equals 3. If something has an undefined slope, then it's a vertical line, meaning it's going to be x equals something. Now it's passing through 0.2, 3, so we plot points. 2, 3 is here. It's a vertical line, so x is staying constant the whole time, so x equals 2. And that's the entire lesson on writing equations of lines. I know that's a much longer video than you're used to, but again, we're going to spend a couple days on this. So as you're doing your assignment, if you need to come back and check the examples, please feel free to come back and forth to the videos. If you need more help with this, there's some more videos on the EduBlog site, eaglebutte.ca. And yeah, make sure you pop in for class. I'm anticipating quite a few more questions with this lesson. So please come into class. Please take advantage of that time that I have to help you. And I look forward to seeing you next time. All right, guys, have a great night.